First week down for our new lessons in geometry. We've learned a lot, but today is a lot of vocabulary terms. So we're just going to get right into it. And again, write it down, draw it out. It's the best way to make sure that we understand what's going on here. So here we go, maybe. Let's see why it's not sharing. There we go. All right, let's just jump right in here. So we talked about points already, about how they are zero-dimensional, and they're just a point on the line. So we can name it as point A or something like that. However, sometimes we need to be able to identify what they are on a coordinate plane. So they can also be identified in coordinates where it has the X, Y coordinates. So if we were on a coordinate plane, something like this, it would be over 1 and then not up or down. So again, coordinates are another way that we can identify points. So today on the Get More Math, it's going to go over all these vocabulary terms. So a point can be also identified by a coordinate. And then let's look at lines. So again, lines are going to be a bunch of points put together. We've gone over that with arrows on both ends, but there's different types of lines that we can have. We can have parallel lines, which hopefully you've seen before. Means that they run next to each other side by side and they never touch. So parallel is never going to touch, and perpendicular are two lines that are going to come together at 90-degree angles. And we haven't necessarily talked about 90-degree angles yet, but the way that we know something is a 90-degree angle is it puts this little square at the intersection of the lines. And if that one is a 90-degree angle, 90 plus 90 equals a straight line, which is 180. So if that's a right angle, all of these are a right angle. So it doesn't need to put it in all of them. If one of them is, they all come together at the same angle, 90 degrees. And then you're going to see something called a transversal. A transversal is used with parallel lines. So I'm just going to copy this and paste it over here. And what a transversal does is it transverses, so goes across other lines. So this is going to be your transversal. So it just basically means it cuts through other lines. Cuts through or across lines. And that just means it's going to make separate angles. So that means I'm going to have an angle here, an angle over here, angles on this side, this side, this side, this side. So a transversal is what's going to cut through other lines to make angles. So we're going to use that transversal. I'm going to draw another one actually so I have more space. And let me see if I can make this. I can't make my laser pointer bigger, so I'm going to have to draw bigger or make it smaller, so I have to draw bigger. So we're going to have our parallel line. And our transversal. Okay. And when we're talking corresponding angles, what this means is if I number them, which usually they do it like this. So just pay attention to the way that it's numbered. But corresponding angles would be angles in the exact same space. So if I have one up here and I take this piece and lay it straight down onto this piece, that means 1 and 5 correspond with each other. And then 2 and 6 are going to correspond with each other because it's the top right, bottom right, bottom right. So 3 and 7 correspond. And 4 and 8 are both bottom lefts, so they correspond. So it's basically like in the same placement is what we're talking about. So angle 1 and angle 5. Or like we said, angle 3 and angle 7. So it's the same placement location. Then we have alternate exterior angles. So we're going to use the same diagram here, but our alternate exterior means outside. So let's just put on here, oops, outside. So it's going to be our alternate exterior angles, meaning if I have 2, my alternate is going to be across that transversal. So 2 to 8. So alternate is opposite. Outside. So that means that we're going to have angle 2 and angle 8 are alternate exterior angles. And then also 1 and 7 are alternate exterior angles. And then we have alternate interior angles. So same thing, it's going to be opposite side, inside angles. Sorry, my pen must need charged. So again, if we look at here, we're going to look at the interior angles, which are the inside in between the parallel lines. So alternate means opposite side of the transversal, interior. So 3 and 5 are going to be alternate interior, and so we're 4 and 6. So 3 and 5 and 4 and 6. And I know it seems kind of silly to go over this, but trust me, we are going to go use this over and over and over and over again. So angle 3 and angle 5 and angle 4 and angle 6. So again, alternate interior, alternate on the inside, alternate exterior, alternate on the outside. Okay, so that's our points and lines. Now we're going to move into angles. So an angle is made up of 2 rays. So we have this ray. I don't know what's going on with my pen here. We have this ray and this ray. So we're going to have a ray here and a ray here. And then the vertex is where they come together. And that creates our angles. So the definition of an angle is where 2 rays come together at a vertex. And then we can define those angles. Oh, I forgot over here. Then they can create a triangle, right? So if I have multiple rays put together and multiple angles put together, I can end up with a triangle. So if I have this one and this one, these are going to be legs where the right angle comes together. And then across from the right angle, that longer side, that is going to be the hypotenuse. And again, going to be super important as we're going to solve right angle problems as we go through this. Something to know is a hypotenuse is only ever on a right triangle, meaning something that has a right angle. It's always going to be across from the right angle. The legs are the other 2 sides of any triangle. Okay, so let's look at our angles over here. We have acute, obtuse, and right. Hopefully you've seen these before. Hopefully you know what those are. But an acute angle is going to be a little tiny cute angle. It's an acute angle. And again, 2 rays and a vertex. So it's going to be less than 90 degrees. If we had to like get a protractor and measure it, which I think we're going to do that through one of these lessons anyway. But you might also see that it's any number between, so that's why I'm putting the X between the inequalities, 0 and 90. So that means it could be 1, 2, 3, 4, 5, all the way up to 89, right? So an acute angle is less than 90. An obtuse angle is going to be a big fat angle. Again, 2 rays and a vertex. And it's going to be greater than 90 degrees. Is going to be an obtuse angle. So again, it's any number and it's going to be between, so that's why it's between the inequalities, 90 and 180. So it's greater than 90, but less than 180. And what that means is 180 is going to give us a straight angle, which is this one over here. Let me jump over to that. Two rays going opposite directions. These are also called opposite rays. Or we could also call it a line, right? And it is going to be 180 degrees. And then our right angle, like what we did with our right triangle, right, is we have two rays that come together, forming a 90-degree angle. And again, it'll give us that little box there to prove that that's what it is. And x equals 90 degrees. And we're going to utilize this, again, pretty much all year long, because when they ask you to solve for the different measurements, you have to be able to identify right angles and straight angles straight off the bat. Then we have vertical, adjacent, complementary, and supplementary. So vertical angles, this is all about the placement. So if I have two lines that intersect at a point, which were our postulates we've already talked about, right? They intersect right here. I can have angles 1, 2, 3, and 4. So that means angle 1, angle 2, angle 3, angle 4. My vertical angles are going to form a V together. So here's this one. That's a V, right? That shape is a V. And if I flip the V upside down, it's 3. So vertical angle, upside down vertical. So 1 and 3 are vertical of each other. So angle 1 and angle 3. And then that means on this way, if we have a sideways V and then flip it the other side, we're going to have angles 2 and angles 4 are going to be vertical. So basically, if you flip it over that point, that's how you find your vertical lines. Adjacent means shares a side. And the two types of adjacent angles that we're going to talk about are complementary and supplementary. Okay, so complementary are going to be two angles, that share a side. So complementary is going to add up to 90 degrees. So we've got this, and we've got the 90-degree box, proving that that is a right angle. But then we're going to add in an angle bisector. So the angle bisector is going to be this glue right here. It's going to cut that angle into two separate pieces. They do not have to be even, right? Just the angle bisector is going to cut it into two separate angles. And then we're going to be able to solve for those angles at some point. So what we need to know here is an angle bisector divides one angle into two parts. Now, sometimes it's a bisector, sometimes it just cuts it in different pieces. If it's a bisector, that means two pieces. We're going to cut it into two separate pieces. Usually they're going to be equal, okay? But again, we'll get to those examples at this point. But a bisector is going to cut one angle into two pieces. If it cuts it into two pieces and it's forming a right angle, that is going to be two angles that add to 90 degrees. And those two angles, let's say this is angle 1 and angle 2. Angle 1 and angle 2 are going to be complementary because they add up to a 90-degree angle, which is complementary. But they're also adjacent because they share a side, right? That was the definition right here. So complementary angles are also adjacent. They're sharing this bisector. So those all kind of go hand in hand. And then my other option over here is supplementary. So complementary adds up to 90 degrees. Supplementary is going to add to, so two angles that add to 180 degrees. So we're going to have that straight line. And then our angle bisector here is going to cut it into two different angles. So we could have angle 1 and angle 2. And then there's lots of things that we know here. We should know that this is going to be an obtuse angle because it's greater than 90. This is going to be an acute angle. They're going to add to 180 degrees. And they're also adjacent because they share this bisector, and the bisector is this piece here. So all of this information is all going to be useful as we're going into how to solve things. Next, we have polygons. Polygons are created by straight edges or straight lines. And that creates, so basically straight lines put together to form a shape. So we have quadrilaterals. Quad means four, right? So that means we're going to have four sides, and we have a bunch of different four-sided shapes that we need to make sure you know. So we have squares where all sides are equal. And if you have little tick marks on each one, that means each of those are the same. We have rectangles where the top and bottom are going to be the same, but the sides are going to be the same, not the same as the top and bottom. So that's why the top and bottom have one tick mark, and then the two sides have two tick marks. And again, they come together at 90-degree angles, right? Then we have a trapezoid. There's a couple ways you can draw a trapezoid. You can have the top and the bottom be parallel to each other. And then you have these two slanted sides, or it can be perpendicular with a parallel side. But the key there is the parallel sides. So trapezoids are always going to have two parallel sides. And then you can have a parallelogram. So something like a kite or not a kite, I'm sorry, a rhombus, where it kind of looks like a diamond. It's like a tilted square. So we have two pairs of parallel sides. Then we have regular versus irregular. So if I have a regular shape, that means that, what was the definition they had in Get More Math? Let me use the exact one just to make sure. Sorry, should have had that written down. So regular shape is all sides are equal and all the inside angles are equal. So if we're talking regular versus irregular shapes, we could have something like this. So regular is all sides and angles are the same. So if we drew a, thought I had a shape thing that I could just pull, but I guess not. If we drew a hexagon, and if it's a regular hexagon, which mine's probably not going to end up being because I can't draw it exact, like that would be an irregular hexagon because this angle is not the same as this angle, right? So not all sides and angles are going to be the same. That would be irregular. If I had all the angles and sides together, or not together, but the same, then they would be a regular polygon. So anytime you're looking at things that you typically see, like if we talk about this kind of triangle, an equilateral triangle, okay? If all the angles are the same, they can mark that with a tick mark, and all the sides are the same, then this would be a regular triangle, okay? But if we have some sort of weird shape, like something like this, that would be irregular because none of those are the same length and same size, okay? Then we have similar versus congruent. So similar is going to be the same shape, not the same size. And congruent is going to be the same shape and size. Because again, we already said that that means equal. So congruent means equal. So if we have, for example, this triangle, and then I copy it and just make it bigger, then those are going to be similar figures. But if I have the exact same thing, then it's going to be congruent. Okay, and they're just going to give us problems where like, hey, we have two congruent figures, or we have, hey, two similar figures. Oh, we're almost there. We're almost there. All right, triangles. We have isosceles. That's going to be two sides are equal to each other. So two sides and two angles. So two sides are the same. Or we can use a word there and say congruent, right? And then scalene is going to be when there's no sides are congruent. So this would be no sides are equal, or no sides are congruent. And then we've already talked about a right triangle. Again, just making sure we know that it comes together at that 90 degree, and it will tell us by the little box if it has the right angle. So that is a right triangle. Median is going to be a middle point. So when we're talking about a median, we're going to talk about a equilateral triangle. An equilateral means all sides are equal. I didn't write that one on there because I just kind of figured you might be okay with that. But the median, I'm going to put in red. A median goes straight from the vertex to the middle of the other side. So that point right there would be the median. So it's the point on a side across from a vertex. Okay. Altitude has to deal with height. So there are a couple of things that you might see for the altitude of a triangle. So if I have one that's not necessarily exactly straight looking, I could have something sort of like this. And my altitude is going to be the height right there. So altitude means height. And then there's also ways that maybe it looks like this. And you can't really get in there like that. So sometimes what they do is they extend the straight angle, and then the height is this way. So that creates the 90 degree angle. So it's the vertical height at 90 degrees of a triangle. Okay, it's the line segment through the vertex and perpendicular line. So just remember it's the height of the triangle. It's the easiest way to go about it. Now, circles are not a polygon. So our definition of polygons were straight lines put together to form a shape. And because a circle has no straight lines, it is not a polygon. So I just want to make sure that you know circles are not polygons, and it's not a polygon because there are no straight sides. Okay, so it's the only shape that's not a polygon, something that encloses space. Diameter versus radius, I'm hoping you have seen that before. So we have our circle, and the diameter is going to be the one that goes from each end of the circle all the way across. So this is the diameter. And then the radius is going to go from the center halfway across. So this is the radius. It's spelled R-A-D-I-E. Okay, so diameter versus radius. I know you've seen those in previous years, hopefully. And then inscribed angle. So an inscribed angle, I'll just copy this circle here. Inscribed means inside, right? So it kind of sounds the same. So inscribed is inside, and it's an inside angle. So sometimes you're going to see these different ways, but it's basically just an angle that is inside the circle. So it could be that they tell you that you have the midpoint of the circle, and then you have 2 points on the edge of the circle, and then it creates, oh, sorry, it creates the angle this way. And we can find the degrees of the angle, okay? So we know circles, hopefully, we know that they are 360 degrees all the way around. And then we can find different missing pieces given the information from the circles. So that's what inscribed angle is. And then a central angle is the angle that has a vertex at the center, okay? So sometimes, like this would be a central angle in green, but let's say we had one that did not. Maybe it was here. And we have an angle that goes like this. This would not be a central angle because it does not go through the center point of the circle. Okay, so central angle are ones that go through the middle, and then obviously the other ones are not. Then we have 3D figures. So if you don't know how to draw a 3D figure, come on over here and we're gonna just draw a square or a rectangle. It doesn't have to be perfect. And then overlap one to like the top right. And again, there's other ways to do this, but this is just how I do it. And then we're gonna connect corner to corner. So from here to here, we're gonna connect that. Top right, bottom right, and bottom left. And that's how we draw a three-dimensional cube or rectangle, prism, or whatever you want to call it. So you'll have plenty of practice because we'll do that over and over and over again. But a face is going to be the flat piece of our three-dimensional figure. And again, depending on how your brain looks at this, it could look like it moves around sometimes. So highlighting and drawing it out is always a good idea. So if we're talking the front face, this would be the face closest to us, which is the two-dimensional flat plane closest to us, right? So the face is going to be the 2D flat surface of the shape. So I could have that yellow piece there in the front. I could have the lime green down here on the bottom, or maybe the top is up here. That's the plane or the face, right? So plane and face, it's called a face when it's on a three-dimensional figure, but essentially it's a flat surface, which is also a plane. Then you're going to have a point. So again, the points are going to be where all of the faces come together. So a point is where the faces come together. And actually it's going to be more than two faces. Let me fix that definition. Where more than two faces. So where all the faces come together. So again, right here, I would have the lime green, the yellow, and then this piece over here coming together. So where there's more than two faces. And the reason for that, and the reason we need that definition clearer, is because the edge is where two faces come together. Because essentially that's two-dimensional planes coming together, right? And it's forming this piece right here. So it's forming a line. So it's an edge is the same as a line, and a point is a point. Okay. So being able to identify those things as we go through is going to become helpful. But an edge is where two faces come together or two planes. So I'm going to put in here, AKA planes. Same concept. And then a cross section is essentially kind of like a transversal for three-dimensional shapes. So if cross section is if we came in here and we cut our three-dimensional shape, the surface that would be shown is what that is. So it's the surface or like the flat surface. Let me erase this. It's the flat surface created when a 3D shape is cut. in half. So what that really means is if we took this top piece off of this bottom piece, there would be a flat surface created because it's a solid shape right there. And that would be the cross section. So again, I know it's a lot of vocabulary terms, but use these notes as you go through the questions on Get More Math. And the more you know them, the better it's, or the easier it's going to be as we go through the rest of the school year with this. So again, if you have any questions, feel free to reach out. I am here for you. And the next 2 days will be mixed review to just continue all of this. So I look forward to the next time.